Yeah, I welcome you again in the second lecture of this series. So, in this lecture, we will try to develop a model for diabetes. So, this will be the outline. So, we will be discussing the motivation, then we'll discuss the glucose insulin dynamics, then homeostasis will be discussed for the thing, then mathematical model will be developed, and then types and symptoms of diabetes will be discussed. So, what is the motivation? Why this particular topic has been chosen to develop the mathematical model? Diabetes is an extremely common disease affecting a diverse age range of people across the world. Diabetes remains the seventh leading cause of death in America. Additionally, many individuals' death certificate cites diabetes as the underlying cause of death. According to WHO, 347 million people worldwide have diabetes. The mathematical model for diabetes, they are helpful for the better management of glucose level and prevention of diabetes. It will be helpful for the society as well as for researchers. So we would like to develop a model for diabetes. Now, diabetes is getting involved with the two terms, that is glucose and insulin. So first of all, we must understand the physiology of glucose insulin dynamics to develop the model for diabetes. So first we ingest the food. Let us say that this is the time t equals to 0 when we have consumed our meal. Then the consumed meal breaks down into glucose absorbed by blood. It increases the concentration of diabetes in blood, of diabetes or of glucose in blood. Then after this increment, beta cell reacts in pancreas and insulin has been released by the beta cell of the pancreas, and it facilitates glucose transport across cell membrane, especially in the skeletal muscles, which reduces the concentration of glucose in blood. Excess amount of glucose, it gets converted to glycogen in liver, and preferably it is the energy storage of cells. If the glucose level is consistently higher than normal level, what is the normal level? It is 70 to 110 mg per dl according to WHO. Then we can say that the person is at the risk of diabetes. Then we can say that what is this reading? This reading is called the reading, random test of glucose. When we are going to path lab, then there are three kind of tests are happening. First tests are there. First is fasting. Fasting means that you should not have eaten anything for at least 10 to 12 hours. Then first is preprandial, that is 2 hours before consuming any meal. And then third is postprandial is 2 hours after having the meal. Then if this fasting, whenever we are saying this reading, this is for random, that is we are not considering any of the three while we are going for the test randomly, that we have not taken food only 2 hours before or only 2 hours after the meal. After that, any time if we are going for the test, that is called random test of glucose. Okay. So that's how it is happening. That this is our pancreas, which plays the key role in that. Then, if there is a higher concentration of glucose in the blood, then insulin secretion by beta cell happens. Then there is an increment in the level of insulin in the blood, which will be triggering fat cells and its other cells to consume the glucose, and then that's how the normal plasma glucose level will be achieved, right? So this then from this one, if this was the situation when there will be this glucose level is high. That is, we have ingested the food, right? Now, on the other hand, suppose we have hunger prank. You might have observed the situation that we are having a hunger prank, and if we do not consume anything for some time, then after some time, that hunger prank is gone, and we feel that we are no more hungry. So it is happening because of this process. That is, pancreas is getting activated again in case of low blood sugar. Then the glucagon released by alpha cells and in liver, they are activating the liver, and liver releases glucose into plasma. And this is the situation where we feel that we are no more hungry, because enough glucose will be transported into the plasma, and our hunger prank will be gone. So that's how our body works. So pancreas is playing both the role. That is, it plays the key role in maintaining the blood glucose level. In even if it is high, then it is making it to normal, and even if it is low, then also it is making it to normal. What is diabetes? Diabetes, everybody know it at this point of time, that earlier it was commonly referred as sweet urine, because it was first discovered in this way only. It is a disease of metabolism which is characterized too much sugar in the blood and urine. So we cannot say diabetes as a if we can say in fever that we are having fever. So we cannot say that we are having diabetes at this point of time, right? There are certain measures which are to be fulfilled before declaring a person is having diabetes. Now, in diabetes, the body is unable to burn off all its sugars, starches, and carbohydrates because of insufficient supply of insulin. This is one reason of having diabetes. It is usually diagnosed by the means of glucose tolerance test. In this one, in glucose tolerance test, 100 gram of glucose is being given to the patient, and then after some time, the test will be conducted, and then the reading will be taken by the for the patient, and then it will be said that according to the reading of this glucose level in the blood, the person will be declared as that he is going to have diabetes or not. So what are the causes of diabetes? There are three main causes. First is that the pancreas does not produce does not produce insulin. That is, here we are saying no insulin. Then second situation is when the pancreas produces little amount of insulin. That is, when it is producing the insulin, but whatever it is producing, it is not enough to bring down the glucose level to the normal glucose level. And third situation is when the body does not respond appropriately to this insulin. That is, our body is having enough insulin, but due to certain unknown reasons, our glucose level does not come down to the normal level. This condition is known as the insulin resistance. All these are the reasons for the increased blood sugar level, which in long term can be said that person is having diabetes. Let us see that how the formation of mathematical model for diabetes will be done. So this is the glucose insulin dynamics. So there will be two compartments in this one. We will be having two compartments. So first compartment is glucose, and second compartment is insulin, because these two are the factors which are majorly involved in the maintenance of diabetes. So first is glucose level. So let us say it is dg by dt. That is, we would like to observe the change in glucose level with respect to time. It will be equal to the glucose production minus glucose utilization. So this is called as the working model. We need to convert this into the mathematical equations. Second compartment is sorry, it is insulin level. That is change in the insulin level with respect to time. This will be again equal to insulin production minus insulin utilization. Now we would like to find out the activity which are producing the glucose and which are making the utilization of glucose. Similarly, we need to find out the situations which will be giving rise to insulin production, and then the situation which will be used for insulin utilization. So this was the first model, was the Bergmans model, which was developed by Bergmans in 1920, and it is like that. It can be written like this. So dg by dt equals to. Now there will be some parameter. Let us say it is some parameter, and this is gb minus gt minus b gt it. Now let us try to understand what is this. See, there will be a increment in the level of glucose with this factor. But what is this B? GB is the basal glucose level. Is the basal glucose level. It is the glucose which is required to be present in our body at all time. That is, below this glucose level, if it goes, then we say that there is a lack of blood sugar in our that there is a lack of blood sugar, and that condition is called as hypoglycemia. When it is above normal, when it is less than the normal range, it is called hypoglycemia, and when it is above this normal range, then we call it as hyperglycemia. Hyperglycemia, right? Why this gb minus gt is, this gt is the glucose level at any point of time. So gt cannot go less than this this basal glucose level. Therefore it will be positive. This is indicated by this parameter, and this term will be positive till this basal glucose level is more than this glucose level at any point of time. Then glucose utilization will be done with the help of this term. Glucose utilization will be done with the help of this insulin at any point of time t, and it will be handled with this parameter b. Right, so that's how we can write the equation for glucose level. Then similarly, let us try to write down the equation for insulin level. Then there will be a release of insulin. There will be a release of insulin in the body when GT will be greater than GB. That is, when GT will be greater than GB, this is positive. Otherwise not. This plus sign, we all are mathematicians, so we know how what it indicates, that it will be positive only when this GT will be greater than this GB. Then only there will be insulin production will be triggered to by this cells of the pancreas. Then insulin self utilization, this is called self degradation of insulin. This is called self degradation, sorry, self degradation of insulin. So for there is a decrement in the insulin level for some which is which is involved in some processes, say that some of the insulin may be wasted because of certain processes of the body. So this is called insulin production, and this is called insulin utilization. Right, so that's how this equation for insulin rate of change of insulin can be written. This was the basic model which was given in 1920, around 1920, and then this model has been you can say redeveloped quite a few times in the history, and then a more refined model has been written, that a coupled differential equation for the plasma glucose and insulin concentration when normal fasting level of plasma glucose is 70 to 120 mg per dl. In this one, there will be this G stands for glucose concentration and H stands for insulin in concentration. So here there will be the glucose concentration is decreased because of the presence of this insulin. Then there will be increment in the glucose if this G naught is nothing but this is equivalent to GB only, that is the basal glucose level. And then there will be increment observed in the glucose level by the food we ingested. So there is an extra term added here for the food we ingested. Similarly, there will be development have been made in the equation for this glucose for this insulin equation also for the change of level of insulin in the body. Now this insulin will be produced only when this G is greater than G naught, that is your GB. Then this is the self degradation of insulin, and it has been modified that self degradation will be happening till this H0, where H0 is nothing but we in some of the research papers it has been called as HB, that is basal insulin level. Basal insulin level, that is, this is the amount of insulin which is always present in our body. So this degradation will be occurring till it achieves this basal insulin level, and further it does not decrease. Then for diabetes, we need to inject insulin from outside, that is in form of oral pills or in form of insulin injections or in the form of insulin pumps. So this factor takes care of that insulin which is given from outside sources, that is, and the sources may be anything. Sources may be, number one, it may be oral pills, then there may be injections, and then there may be artificial or insulin pump. So all these things will be taken care of by this I6IT. Okay, so that's how the model can further be organized. And then this has been, sorry. Now, then it has been given, this more refined model have been given for this blood glucose level, that instead of these parameters, we have defined the functions which are behaving for a particular phenomena. Here these we call them sensitivity constants, and here we are taking them constants, but in further studies they have not been considered as constants, and rather they have been taken in the form of functions according to the biological conditions, according to the biological phenomena which is happening in our body, which mimics the situation of our body. So if we, if I write down one of the equations, then it is dg by dt equals to, let me say, G infusion minus F2 GT minus F3 GT IT plus F4 5 IT. So in this one, instead of this L1 and instead of this L2, we are having this F2 GT and then F3 GT IT. So this is function of GT and IT. Similarly, instead of this L3, we are having this F5, and here we are having this IT because what we say, the production, the changes in the glucose level will be happening because of the occurrence of insulin. Then we can write down the equation for insulin, that is di by dt is F1 GT, because there will be change in the level of insulin because of the presence of glucose only, because glucose was the factor which triggered the production of insulin, and then there will be self degradation of insulin is happening, so that it can be written like this. In some of the articles it has been written as like this, that is IT minus I0, where I0 is the basal insulin level which has to be present in the body at any point of time. So that's how, more complicated models can be created, can be developed with this, with more and more conditions are included, then more complicated model can be developed. It will be more complicated for the sake of computation, for the sake of stability analysis and all other things, but it will be representing the real life situation in a more closer way. So that's what we have discussed, that how a working model can be converted into a mathematical model for diabetes. So let us end our second lecture, and we will meet in third lecture, where we will try to develop a model for infectious disease. So thank you very much. Stay safe. We will meet again.